Good morning, Professor. Can you hear me?
Can you just say a couple so I can check?
Yeah, I can. Good morning, Professor. Can you hear me?
Yes, that's good. I'm going to switch off my webcam so that I save bandwidth.
Okay.
I hope that's okay.
Okay, sounds good. Yeah, no problem.
Hi. Can you hear me all right if I ask a question?
Yes, I can hear you perfectly.
Okay, I won't ask any questions until I'm asked though, so I'll also mute myself in case there's some feedback.
Okay.
Okay. So we'll start in a few minutes. So maybe after 1 minute, something.
So I'm not sure if you met before. So, Professor Kessentini from Michigan State University in privilege.
So we can start. So good morning, everyone. So thanks for coming to the Ph.D. defense of Mr. Mohamed Wiem Mkaouer. So his Ph.D. dissertation title is about balancing competing needs of machine and human software refactoring. So Mohamed, maybe you have around 15 minutes to present your research contributions, and after that, you receive questions from the committee and also the audience. Then after that, maybe you take minutes to discuss the discussion.
So thank you, Professor. Good morning, everyone. First of all, I want to love to thank the committee for accepting to review my work and good time to prepare it. And also want to thank my colleagues and my friends who came here to support me. And today I want to share with you my PhD experience, which is entitled Balancing Competing Needs Between Machine and Humans in the Context of Software Engineering in general, and more specifically, the context of software refactoring. So to introduce this, of course, I will go through mainly the context of the software maintenance, which is where I've been working in my 4 years of PhD. Then I'll show you the whole picture, or the big picture of all my contributions through the different team layers of the software. Then I'll talk about mainly, for time constraint, I'll focus on 2 of my main contributions. Then I'll give you some future direction before I conclude. So to start with, my work is situated in software maintenance, which has been detected as the bottleneck of the software lifecycle that's been for so long, and we noticed that software maintenance has been taking up to 67% of the budget of the software and this has been detected as the early years of 2000. And then we noticed that how this has been a challenge for developers, mainly to work on the software maintenance, especially that 76% of them has been working in software maintenance-related tasks. And within this time, we have 60% of their time they spend just trying to understand the source code. And with all this effort being done, we noticed that we have up to $60 billion of software failures, every year. And this, this, of course, this reference is a little bit outdated. Now we're talking about $3 trillion of loss every year. So we notice here that we have a big challenge. The growth of the software is pushing the software quality into a challenging level in which we have to face maybe using one of the several tools. One of them will be, software refactoring. So software refactoring can be defined as the art of taking an existing software, trying to change its internal structure to improve the quality without changing its external behavior or the functions of the system. And this is being done through mainly two phases. The first one is taking and looking for the candidate piece of code that needs to be changed, and usually we refer them as bad programming practices, or what we call also design defects. And the second part is try to look for the right code changes that we have to do in order to fix these design defects. So to start with, designing design defects are usually symptoms of bad programming practices. And in 2015, an XC paper has shown that even programmers, senior developers with 20 years of experience, they still can introduce design defects into the source code. So it's being either introduced during the initial design, when we first start working on the software, or also when we are actually updating the software during the evolution level. And one famous example of a design defect can be the blob, which is a module or a class which is abnormally large. It has several methods and several attributes, so you can see right away that it's really large. And also it's coupled to mainly several other classes that used to be or tend to be data classes, so they don't have much of functionality, don't have much of methods. They mainly have attributes. So this kind of symptoms you can see right away in the source code, and it will be bad, of course, for the developer to be, if the developer is asked, for example, to update such source code, it's hard for him or for her to understand such, source code or such class to update. So it would be better for any developer to see something like this. And this is just one example of what can be a good design compared to this design. And this design can be done, for example, based on, for example, splitting this class into several classes, or minimizing it, or distributing, or moving methods, or moving attributes from this large class into several classes to have a better distribution of methods and attributes, which give better distribution of the function of the system, in classes. And this can be done through refactoring and through the choice of the right operations to do. And this is, of course, one kind of a good design. We may have several other candidate designs that can also give good understanding for the source code. So my work is mainly about how can you automate finding these operations that can take this bad design into a better design. Of course, and this is going to follow some criteria that we will see throughout this session. So the big picture of my contribution would be, if I had to summarize my PhD, I can summarize in one word, which is transformation. Transformation can be done in the model level. And in this work, I've been working in the model transformation, which is part of the model-driven engineering. And I was able to come up with a multi-objective model transformation, which is able to transform a model A into a model B, source model into a target model, by finding the right transformation rules that can move the meta-model elements from the model A to the meta-model elements of a model B, and this while trying to minimize the complexity of transformation while maximizing the quality of the transformation. So the transformation, this is of course what we call also the exogenous transformation. I've been also working on the endogenous transformation, which is transforming the elements from a model to itself or a language to itself. And in this context, I've been working into the code level. In the code level, I've been working in the package level, in which I was able to investigate for the first time the incorporation of several preferences of the developer into the into the problem of software clustering. And I've been also working into the source code level, in which I've been working into several contributions. One of them was that since the source system or the the software development is so dynamic, we may end up having, the developer may have preferences that will change over time, and this will create a noise during the optimization, and this from where we come up with the software, refactoring under uncertainty, in which we try to come up with robust solutions, which can maintain a little bit of quality to give, more, freedom to, this uncertainty of the developer in terms of what classes to update and what code smells, to fix. And then I've been working also on incorporating as many preferences of the developer as possible in terms of, also many objective software refactoring. So this is kind of similar to this work as well. And then I've been moving from the fully automated techniques that I've already seen here into more interactive techniques that I try to incorporate the preference of the user during the search. And by doing so, the first investigation was by trying to inserting the preference of the user as a reference point during the search. And this is, of course, was the first time to investigate, for me, investigating such, such approach. And then I tried to go more into that by integrating the developer completely into the loop of the optimization process. So throughout all this work, I've been trying to optimize the quality of software. I've been trying to find the right compromise between fully automated techniques and user interactive techniques. And this is all being done. And the common point between all these, approaches or solutions is the use of search-based software engineering, which is the art of taking software engineering tasks and looking for the right, defining as optimization problems, and look for the right search algorithm that can be mapped into the software engineering tasks and to optimize it through a fitness function. So, like for example, if I take any problem of these in the literature, we've been already looking for, or we can find a lot of algorithm that has been already used to solve these problems using several fitness functions. And this is being done. Like if you want to take a software engineering task and define it as a search-based software engineering problem, you have to follow these 3 main steps. So we'll have to take the software engineering problem. Let's take the example of the model transformation. So in this case, our problem is to come up with a transformation rules which take you from one model A to a model B. Let's say we are going from the class diagram into the relational schema. So we need the right transformation rules to do that. So our solution here will be a sequence of, or a tree of rules. These are transformation rules that can map, one element from the source model into an element to the target model. Let's say we can have a transformation rule such as if class A then equals table A, or if, for example, attribute B equals field and primary key, B. So we may have several ways to map one element from the source into one or more elements in the target model. And this can be our solution representation. Then we have to evaluate this solution and see how good are, for example, these transformation rules. We can, for example, evaluate them with using several criteria that the developer may choose. One of them can be, for example, the complexity of the transformation, that we want, of course, to minimize. Another thing is, of course, to minimize or maximize, for example, the quality of the transformation. We want to have, a target model which is as concrete as what the user is expecting. And this also is very important as, to define, because this is where we actually get close to what the developer wants. And then we have the change operators, which can also be deployed to update this solution in case the solution is not as satisfying or satisfy this fitness function. So actually what we're doing is we are in a closed loop in which we are taking a solution, maybe randomly created depending on the source that we are deploying. Then we have to evaluate it, and then we have to change it, and then we keep evaluating and changing until we find a solution which is satisfactory to the developer. And by taking a search-based problem, then we are defining, we're taking a software engineering task and we're defining it as a search-based software engineering problem. So my main work actually that I'm going to focus on today will be the many objective software clustering and the interactive dynamic software refactoring. And these 2 main contributions are actually answering the following questions. Why the incorporation of the developer is so hard in software engineering in general, and software engineering and refactoring or remodelization in particular. And as an example, we'll see that we've been already seeing in the related work several criteria that has been used, to actually come up with a better designed system But we notice also that these systems has there's no solution which has incorporated as many of them together. And the question was why? Why don't we just do that? And we'll see through an example that this can be beneficial to the quality of our design. Also, we'll try to look at how can we come up with a better way to define the sweet spot between the fully automated techniques and user interactive techniques. We'll see both. We'll see mainly the fully automated at this level to the first contribution, and we'll see what are the problems and the challenges that we can also see to this contribution that can drive us into the second contribution, in which we try to find another way to also incorporate the developer's preference by inserting the developer into the the group of the process. And this will be the subject of our second contribution. So to start with the first one is actually mainly tackling a famous problem of updating the existing softwares. Usually with the growth of the software, we have several classes to add into the software. And for example, for the case of Java, we're talking about exercises, so this is a Java case. So these are packages and these are classes. So these software, as it evolves, will have several classes to include to the system, and this will add a lot of classes that can be added into one package. And one way to redesign the system to make sure that it's still coherent is to, for example, take some of these classes and move them in other packages. By doing so, you may think that, for example, if this class can be moved somewhere else, then we may end up having candidate other packages that can be hosting this class. So as a developer, you may think of how can you decide about where to move this class. It's a good question. So we have several ways to think about this problem. So one way is to, for example, optimize the structure of the system. We can think of looking at these three packages and say, okay, we have 2 classes per package here. So it makes sense to have a good distribution of classes per package that we can move this class into this package. It makes sense from structural perspective. But this may not make sense from semantics perspective, because this class is actually belong to a package which is responsible for reading XML files, and this class is also, the function of the class is actually belongs to that level of reading XML files, while this package is actually hosting classes which are responsible for violating the schema of an XML file. So the functions of this class and these classes are different. So if I move this class into this package, I would optimize the quality from structure perspective, but I will violate the semantics of the program. For that reason, we notice that we may have several objectives that we can include while they're doing this kind of decision making, and these objectives tend to be conflicting. And by deciding that we should not move, for example, our class to this package, we may end up having 2 candidate packages that can be hosting our class. And these two packages, they actually preserve the semantics of the software, because both of them host classes which are also reading the XML files. So then we'll be thinking of which one of them will be, for example, our candidate. From semantic perspective, it's the same. From structural perspective, it's also the same, because these two have also the same number of classes. Then we may think of adding more, criteria into the picture. We can think of, okay, if we look at the history of changes from this software, we notice that developers previously have moved, classes from this package into this package. So it does make sense for you as a developer to follow what the developer has previously done. And by doing so, you may think of, okay, now I have enough knowledge and I can take this class into this package. So we notice that the decision-making of moving classes among packages may be, we may have several criteria that we can put in the picture together to have a good decision about where to move this class into this package. So, and that's what the related work has been doing so far. And since we're talking about clustering, I'm going to cluster, the related work into 4 packages. The first package is all related work, which is actually trying to, optimize the structure of the system in terms of coupling, cohesion, in terms of number of packages, number of classes per package, etc. We have another package in which we are trying to preserve the domain semantics. We have a third package which is trying to minimize the number of changes without the design, because developers don't like to see their original design changing a lot. And also we're trying to be consistent with the history of the previous changes or recorded changes. So these are the 4 clusters in which we find out, like we have several with work, which mainly some of them are purely, for example, optimizing the structure. Some of them, they overlap between structure and domain semantics, or structure and, consistency with the history of changes, like this example, etc. And the obvious question here, and from what we have already seen, it does make sense to include all these objectives together, because all of these are actually preferences that can help us have a better decision here. So why not just taking them all together? This is the question. And the answer to this is that all the search-based techniques that exist right now, when they go into a higher number of objectives, they face a problem. The problem is that once we hit a high number of objectives, like for example, if we take the previous example we have here, for example, four metrics, we may have here 2 or 3 metrics, we can have here 1 or 2 metrics, etc. So the number of objectives may go from 6 to 8 very easily, and by doing so, the number of non-dominated solutions that we create to solve these problems, they become mainly, all of them will become equivalent at some point. And this is during even the first generation of the search. And things will get even worse, because as early as the second and third iteration and generation of the search, we notice that we have up to 90, even maybe more than that, of solutions which are equivalent. And this is, of course, going to make it hard for the search to distinguish between good solutions. And this is going to also trigger some kind of a random behavior, since we are no longer choosing the solutions that converge better, we just choosing solutions that have better diversity. And also, this is, of course, will require a better selection process to have a better convergence. And from this perspective, we decided that we will take the problem of software clustering into a many objective search problem, in which we'll have to take, for example, 4 structural measures, to enter the picture in terms of number of packages, number of classes per package, cohesion, coupling. We have also the semantic coherence, defined by the vocabulary of the system in terms of comments, the similarity between the comments, similarity between the source code, and also the similarity in terms of code graphs and dependency between classes. And in this case, we are looking at dependency in the attribute level and dependency on the method level. So if 2 classes are using the same or sharing the same attribute, or using the same attribute, we say that these classes are they are dependent. And also, if 2 classes are calling the same methods, then also decide them to say that they are also semantically dependent. Also, we want to, of course, minimize the number of operations, and also want to always stay consistent with the history of changes. And to also have a better, since our search is being exploded, we're having a high dimensional space to search. We also included several new types of operations to have a better search possibilities to the search space. So this is our proposal, in which we take all these criteria into the picture, and we try to come up with the best sequence of updates into the source code that can give us a better design system. So to follow up with this, so this is the problem. This is my proposal that I want to define as a search-based proposal. To do so, I have to come up with the first thing, which is the solution representation. So here I have 4 or 5 operations that will actually be used to come up with new changes or solutions. Each solution will have several operations that can update the source code. These solutions, for our case, will be created randomly at the beginning, and we'll try to optimize them throughout the search. And this optimization will be done through the evaluation. This is being done using several objectives. So we have here the first 4 structural metrics, like in terms of number of classes to package, number of packages in the system. If we consider only these 2 objectives, we will end up building each a package with each class. And then and this is, of course, may not be good, because we can have a very high coupling by doing so, and also very bad cohesion. So these conflicting objectives together will actually be the one that we have used for the structural metrics. Also, we have the semantic metrics that we have also considered, which is the vocabulary-based similarity, which is a precise similarity between the tokens or the words or the keywords used on the source code. And also, we have the dependency-based similarity, which is based on the shared attributes and the shared methods. And also, we have other metrics in terms of trying to minimize the number of operations that we have to deploy. as well as being consistent with the history of changes. So these will be our 8 objectives that we have to deploy into the search process. And the third step, of course, to actually also define is the change operators. And here we are using the crossover and delimitation as part of the NSGA 3, which can be done in this lecture. So the first thing to do is to create randomly several solutions. These solutions will define our first population. So we'll have a parent population which will have several solutions. Each solution will have several operations. These parent population will take candidate parents and will apply the crossover and the mutation to come up with the offsprings or the children. These solutions also will have several or same genes from the parents, and will have to they may be either better or maybe bad compared to the parents. So to be able to know, we'll have to put them all together and apply the non-dominated sorting to rank these solutions. The non-dominated sorting will tend to create what we call fronts. Each front will have several solutions which are equivalent, and we always want to have the best solutions will be allocated on the first front, the second best on the second front, etc. And this is by when we'll have the fronts, and of course we'll start to pick the best solutions based on the number of the front. And as we have previously said, when we have several objectives, these fronts tend to be less. We'll have maybe 1 or 2 fronts, or even 1 front probably by the 4th or the 5th generation if you are using a regular multi-objective search that has already been used by the logic way. For that reason, they will be mainly working, and the distinction here between the solutions will be based on the coding distance, which is diversity criteria, and this is where the actual written work starts and no longer be able to product, and this is when things will change for our case, because we'll use the niche preservation, which allow us to have a better way to distinguish between good solutions that can optimize several objectives in a time and guarantee the convergence and the diversity during this process. And this is how we'll be able to have good solutions that satisfy all these objectives together. So to validate this work, we'll look at 3 main validations or 3 main research questions. The first one is to see how we'll look at how they improve, how come these solutions, they improve the packages of the system. So we'll have to do the manual correctness. So we'll ask the subjects that we'll see later to actually go manually and validate the operations that we will propose through our technique. The second research question will be to what extent these objectives improve the suggestion good optimization solutions. And this will try, by doing so, we'll try to replicate what have already previously done by the developers, because we have already the history of previous changes. So what we can do is we can go to an earlier stage of the software and see if we can replicate the changes that has been already actually done by the developers. If we can do that, then we know that we are actually close to how the developers think in terms of updating source code. And the third research question will be, how does NSGA thinking perform compared to other mono, multi, and many objective techniques? And this will be done through the comparison between them. So the experiments has been done into 4 medium and large open source systems. As these are open source systems, we have chosen them because we have several releases, and we have regular changes between these systems that we can, take and use either through the manual investigation or through tools such as Refactoring, which can tell us differences between them in terms of course, updates in terms of refactorings. And then we have also the tuning parameters for the several search-based, techniques that we have already, deployed. And also we have the evaluation, which is being done through several subjects. We have a group of students that help us, and also some developers from our industrial partner that are also, help us with this evaluation process. And the way we did this is that we took, several solutions proposed by our algorithms, and for each algorithm, we will have several objectives. So each solution will have actually to minimize either 2 to 3 to 4 to 5 objectives. So these solutions will be all tested, by the groups based on several systems. And then we'll ask these developers to, evaluate, how good are these solutions. So the manual precision will be the number of coherent operations, the number of operations that make sense to the developers, divided by the overall number of, suggested operations. And we notice here that we can cluster again the results into 2 groups. The first group is the family of many objective algorithms. We have NSGA3, we have the indicator-based evolutionary algorithm, and we have the decomposition-based evolutionary algorithm. And the three of them, they are actually doing good because the three of them are made to handle several objectives. So they are able to somehow have a very good coherent operations that were able to actually satisfy the developers. The second set, you'll find the mono and the many objective algorithms, which fail to somehow have better good results compared to the many objective algorithms. And this is due to the fact of them aggregating objectives, so they lose in terms of search to find good quality solutions. And also we have one multi-objective technique which was able to actually have a good also results compared to the family of the many objective algorithms, which is the work of Professor Gabriel Bavota in 2013, which incorporated the developer into the root of the search. So here we have developers looking at the solutions at some iteration of time and saying, oh, this solution is good or this solution is bad. So the ranking has been done to the developers, and by doing so, they will be able also to have as good results as the many objective algorithms. So to take the work of Professor Gabriel Bavota, or the interactive genetic algorithm, and we put it here, I'm trying to compare our algorithm against it. So here, this is NSGA3. This is NSGA3 using only 2 objectives. This is using 3 objectives, 4 objectives, etc. We noticed that NSGA3 was able to outperform, the interactive genetic algorithm only when taking into account several objectives, mainly the history of changes. And this is due to 2 things. The first thing is that the developers that actually evaluate these solutions may not have a good knowledge about the history of changes or keep track of it, and also this evaluation may be very subjective, so it may change from one person to another. So yeah, and this is what makes the difference between these 2. But actually, this is of course a very good work, which also has been an inspiration for me personally to maybe move to actually to something which is similar in the next steps. So for the automatic validation, which is looking at how can we replicate what has already previously done. Again, we notice that the family of many automatic algorithms, it does good. It does a good job in terms of replicating these operations, and also the work of Professor or the interactive algorithms also doing a good job. And of course, the mono and the multi-objective techniques, they fall behind. Now, if I want to compare between the evolutionary algorithms, we have the 3. We have compared here. We are plotting the Pareto form of 4 algorithms. The first one is NSGA3. The second one is the decomposition-based evolutionary algorithm. The third one is the indicator-based evolutionary algorithm, and the third one is NSGA2. And in this plot, these are the axes here are the several objectives, which are all to minimize. So the closer are we, these are the values of the solutions in the last front. So the closer are we to the search, to these values, the better is the convergence. And we notice that NSGA3 and the decomposition-based evolutionary algorithm are doing good in terms of convergence compared to this previously 2. I noticed that NSGA2 was, of course, falling way behind because it cannot produce good solutions because of the high dimensionality of the search space. And in terms of diversity, we notice that the diversity will be defined based on the several values that these solutions can take. And we notice that among these solutions, NSGA has the highest number of several values it can take into the search space compared, for example, to the decomposition-based algorithm. So NSGA3 has something to give us both good trade-off in terms of convergence and diversity. So the outcome of the first question would be yes, we can actually come up with several objectives together and put them together in terms that can represent the developer's preference. And by doing so, we can break the boundary of having up to 4 or 5 objectives in the search, and this will ensure scalability. But also, when we were applying our techniques, and mainly with the validation, we noticed that we have other problems. The first problem that we noticed is that we are generating large solutions with a lot of operations that we give to the developers, and developers may not be able to execute all of them. Sometimes they will have constraints over the source code. Sometimes they will have packages or model or something they will not want to touch. And for us, we cannot allow them not to apply all of the solutions. So it's like either take it or leave it, which makes our solutions sometimes impractical. Another thing that we have noticed as well is that developers sometimes they want to execute some of the changes, do other things, and then come back and continue the changes. This is also not allowed by our solution. So we cannot also allow the developers to have such kind of setting in which they can postpone execution of some of the refactorings compared to others. So these were the two main limitations of this work, that inspired us to move to the next level in which we try to fix these two limitations. And this has been done mainly through the interactive dynamic software refactoring. So to sum up the refactoring, we'll still, now we move from the package level to the source code level. And if you look at the existing work, you notice that we have two main, two main families: the manual refactoring techniques, which will take the developer to look at the source code and come up with a candidate for portions to fix, and then they will look for the right, operations to apply. And then we have the fully automated technique on the other hand, which will come up with a long sequence of refactorings that they have, of course, to apply. And we have within the fully automated techniques, we have the analytic approaches, which will try to come up with deterministic ways to say, okay, for this kind of problem, we will apply this kind of, refactoring. Let's say for the existing, for example, of a blob, like we have previously seen, we can just apply extract class and split these classes until we remove the blob. So these analytic approaches are also efficient for fixing such, candidate problems, but also they fall behind because they are limited to a specific set of code smells or defined design defects and a specific set of refactorings to apply. While the search-based techniques, they can do better. So they can take into account several, defects that they can fix, and also they can deploy several refactorings to fix these defects. So they give you more flexibility in terms of, redesigning systems. But the problems with both of these techniques is that the first manual refactoring, of course, it's time-consuming, it's human-intensive, and it's error-prone. While for the second one, they have the same problem that we have previously seen in our, in our work, which they lack flexibility and they do not consider the developer's feedback. So how can we come up with a better way to do this? So how can we come up with something, in the middle? So to do so, I would look at, a running example that I will go through to show you how I can propose a better way to do this. So I'll be looking at, the offline phase. So in this offline phase, I will just run the NSGA2 to generate refactoring solutions. Which one of them will improve the quality of the software, and this can be, be done through several, objectives or several criteria that we can use. In the literature, we've been, familiar with several quality attributes like the Q mode, like the mode, like the work of CK metrics that we can use to come up with a, to measure the quality of source code. So this can be generic. This you can use any, quality criteria or attributes to deploy to come up with the good quality of the software. The second objective here is, of course, to minimize the number of uploads that we can deploy. So this offline phase will be done through the NSGA2. The first, the NSGA2 will be taking the source code, list of refactoring types, the list of quality attributes, and then the semantics together that we can combine into the quality level to come up with a good quality, model quality, and then we have to reduce the complexity of the refactorings. So we'll apply the NSGA2 the same way we have seen previously to come up with good solutions. These solutions will be next ranked. So here we'll be deploying a ranking process. This ranking process will allow us to take several solutions. This belongs to the Pareto front and look at the common features between them. These common features can be, for example, like similar operations that they can have. So this will be done, for example, through the extraction of 3 solutions. These solutions may have common operations, as you can see here, and we're trying to come up with a ranking which will give us the solution that we will deploy to the developer that has a higher, a higher rank. So by doing so, we'll have, for example, this is our, ranking process, which has several solutions that, we'll have for each solution. We look at all the refactoring operations and then rank them based on the redundancy among all the other solutions. So a solution which has a high number of redundant operations or common operations, it means it's a good solution that we can present to the developer. So after the ranking process, we can send this list of ranked refactoring to the developer, and we're going to show take the candidate solution and show the refactorings of this solution one by one. So we'll show the developer the first operation, and we'll ask the developer to either apply or modify or deny this operation. The developer will have a choice to actually either apply it or modify it or deny it, and by doing so, we can look at how this ranking will be updated. So we'll take, for example, solution 2 as a good solution that as we start with, because it has a higher initial rank. Then, if the developer is going to accept this solution, then this solution will be having a credit for being accepted. So we'll have, for example, +1, and any solution which has the same refactoring will also have a good, will be a credit for that. And this is how we'll update our ranking of our solutions. So far, solution number 2 is being, the solution that is candidate or it's higher with a higher rank, so it's just the one producing the operations. So in the second iteration, you notice that the developer here has changed the class which is supposed to be the target class for moving this method. So by doing so, this solution, which is proposing this refactoring, will get a partial credit, and any solution which has, this exact refactoring that the developer was looking for would have full credit for it. And this is how we will keep updating our, ranking process. So, and also we'll keep track of the list of applied and rejected solutions. And we notice here that the developer, for example, has rejected this operation. So these solutions, by having this rejected operation, will get penalized for it. And any solution which has also this operation will be also penalized as well. And it's not the case for these two solutions. And we notice here by doing so that this solution now falls behind because this solution now has a better score. So the next operation will use this solution to come up with the refactoring that can be applied by the developer. So we'll also, in the next step, we'll take these, these operations that the developer has either accepted or modified or rejected, and we'll put them back into the search process, which is going to take them as constraints in order to keep moving, and we'll continue the search here in order with taking into account these operations to have to converge towards a better preferred zone for the developer. So to give you the big picture, the first phase will be the offline phase, in which we will run an SGE2 fully automated without any interference with the developer. Then we will move to the ranking of the solutions. This ranking will be based on the common features among these operations. Once we take the best solution, we'll move it to give it to the developer. The developer will give us the feedback, either by accepting, modifying, or rejecting these solutions. By doing so, the developer will be able to optimize the code already, and also it will allow us to take this feedback and incorporate this feedback into the search process to move towards a user-preferred, search zone, and come up with more customized or user-preferred solutions during the next step. And this will be going a cycle until the developer decides to start, this process. And this process is actually, triggered spontaneously by the developer. The developer has a choice because this is a plugin that is being integrated into Eclipse. The developer has a choice to trigger this process anytime and stop this process anytime. And this is, of course, in contrast with what we have seen previously in our work. So dividing this work, we're looking at 3 research questions. The first one is, to what extent our approach will command relevant refactoring to developers? So here we'll look at, mainly the precision and recall, and how many code smells, we can fix through this process. Also, we'll be looking at to what extent our approach can, or will try to, test the efficiency of our ranking process. And the first, third question will be looking at how useful and how meaningful, our approach can be done, in a real-world scenario. So for this, we'll actually be looking at, several also open-source systems and 2 industrial projects. First one is GDI4, which is a software which is already has been there since 2006, so has been there for 10 years. It's being used by Ford Motor Company to deal with the request of dealerships. So the developer, the Ford has several dealers that have several requests for cars, and Ford has several criteria. Actually, they have thousands of them to come up with the best distribution of the cars among the dealers. They have, of course, based on the availability, the productivity, the price, and they have also based on the priority of the dealers, etc. So they have several criteria taken into account when they are dealing with this. So this software manages that level. And for the second software, it's being used by the marketing, company, the marketing, department in Ford, which is based. It's a return on interest application, which is able to, predict the sales of the cars, and then tell them, give them some indications about which cars it has to produce more to have a better profit. So we made several scenarios to test our approach. The first scenario will be to take existing software systems and extract 9 classes among these systems and ask the developer, ask the subjects here to fix mainly 2 code smells. And then we will see that, and we will record their changes, and we'll try to see if we can replicate these changes using several techniques. The second scenario is to take these changes and cross-validate them with the other subjects and see if they are meaningful or not. The second scenario will be to ask developers to fill out a questionnaire. We'll see this questionnaire later. It's mainly 2 questions to tell them, to give us a feedback about our approach. The second one is to create 2 real-world scenarios, or at least to simulate it by giving the developers 2 bugs to fix and also 2 features to add. We made sure that these, bugs and features are easy enough, so they don't take time because we have only 2 hours frame, of time that we can apply these. And we'll see how the developers can fix this into a non-refactored code, how much time they spend fixing these bugs and updating the features in a non-refactored code against a refactored code. So for the first one, for the first results, we're looking at the precision and recall. So it's the ability to replicate what the developers has done. And we noticed that most of the existing work, was able to have good results. And our approach, as long as it's incorporates the developer into the loop, it's of course was as close as possible to what the operations should look like. And this is of course makes mainly because the developer is actually applying their refactoring himself or herself. For the number of code smells, we noticed that our approach has not done as good as the others. And this is mainly, maybe, can be explained by the fact that the other approaches, such as the multi-NSGA2 here, which is trying to maximize the number of fixed code smells and minimize the number of code changes, and also the mono-objective algorithm, which is also doing the same thing, they are actually having the number of code smells to fix as part of their fitness function. For our case, it's not the case. We're just trying to optimize the quality, and also we give the hand to the developer, to choose his or preferred, operations. And by doing so, we may not be oriented directly to fix, as many code smells as possible. So we give more flexibility to the developer, and this may, may allow us to maybe not fix as many code smells as possible, but at least satisfy the developer, and their work. So for the ranking process, we look at the top 1 and 5 and 10 and 15 of the ranked operations that we actually suggest to the developer, and see and test how many. And we saw the manual correctness among only these operations. And we noticed that we were able to actually suggest meaningful operations in most of the times. And also we will be able to replicate what has already previously done by other developers in most of the time as well. And this shows that the ranking process is learning the behavior of the developer through several sessions. Also the same session, with several search applications or through several stages of the search. And then to test the impact on the productivity, we're looking at the number of minutes required to perform a task, before or after, so the refactoring divided by before. And we notice that we have already optimized the time that the developers would spend, when they're trying to fix, or trying to, for example, fix bugs or add the new features. And this is due to the fact that they are getting more familiar with the developer the system as they refactor it, of course, and they'll give them more, understanding of the software as well, because it's designed the way they want, of course. And the feedback that we had from the developers using the questionnaire was very outstanding, very interesting, because we gave them 2 questions, which is, does they really find that this is a reusable feature in IDE, mainly Eclipse, and the answer was, of course, yes, they liked it. And also, if they found this is a flexible way enough to refactor compared to the fully automated approaches, and also their feedback was positive. So this work was able to, give an approach which is has the advantages of the fully interactive approach because it still have a fully automated way inside it, and also was able to incorporate the developer into the loop. It's different from the classic interactive approaches because the classic interactive approach asks the developer to actually evaluate the operation during the search, which we don't do because the evaluation of the solutions during the search is really tedious and time-consuming. But in this approach, we are actually helping the developer to do what they want to do through, and we are also learning from their behavior as well. So it's a different way to look at the interactivity with the developer, or how to incorporate the developer into the search. Because the developer, the search is transferred to the developer. The developer, they don't know about the algorithm. They just see the operations. They don't see the solutions. They only see the operations that they can either apply or not. So we guarantee flexibility, so they can actually have the ability to apply refactorings and then stop and do different work on different things and then come back to the refactorings. Also, we allow a new novel way to do interactivity. As I have previously said, they don't need to evaluate every solution during the optimization. And also, we were able to incorporate the advantages of the fully automated approaches and have the dynamicity of moving from solution to another into the search space without asking the developer to go and specify what solution she or he may like. So we would just do that by moving through the ranking process. So these are the main contributions that I have done. And as a future directions, these actually future directions, they're also coming from the feedback that we get from the developers. Because one main question that we were facing was, once we are applying these refactorings, is how much of a time we need to test these changes. Because after all, what we are suggesting so far is all code changes. And every code change will trigger at some point of time regression testing. So we need to prioritize and update the test case. We have to retest the systems as we are changing them. And how would you do this? How would we be able to estimate how much of testing effort we need to do that? That's a question that we cannot answer as for now. And for that reason, this also work may need to be also further be taken into the level in which we can look at how much time we need to test the system after refactoring it, or even maybe how can we come up with also test cases that we can suggest to the developer as well as the code changes. And that will be the subject of my next future work, in which I'm trying to incorporate the regression testing with the refactoring. So I would still suggest refactoring operations along with the test case that has to be added or updated or selected for the testing process after these test cases. And by doing so, I will try to look at the multitasking paradigm to do that. I'm hoping that by doing this, we can, reduce the vulnerabilities that we can introduce when we are refactoring our system. So to conclude, I've been working or fighting for the source code quality. I've been trying to optimize the quality into several levels into the software, into mainly the model level, the package level, and the source code level. I went and I was able to incorporate as many preferences as possible of the developer to see how can we come up with an ideal way or more realistic way, to optimize the design of the system. And we saw that we can do this. It's scalable, but it's unpractical. And then we moved from the fully automated technique into more interactive technique, in which we incorporate the developer into the search process by getting its feedback and by giving it the hand, to apply our refactoring with more, flexible manner. And finally, we're looking at how can we come up with the multitasking to incorporate the test with the refactoring. Thank you very much.
Thank you, Mohamed, for your presentation. So, I have questions on the meeting. So, maybe we'll start with our guests. So, Professor Marouane Kessentini, Professor Qiang Zhu, and Professor Medjahed, and finally, Professor Maxim. So, Mark, yeah, I finally need. So, and we needed another round of questions. Mark, can you hear me?
I can, yes. Can you hear me?
Yes, we can hear you. So you are the first committee member to ask questions for Mohamed.
Okay, thank you very much, Mohamed. I hope you can hear me okay. Can you hear me all right?
Yes, perfect. Yes, I can hear you.
So I can't actually see the screen because it's bleached out, but I could follow your slides because Marouane kindly sent me a copy of the slides in advance. So in answer to my questions, I'm afraid you won't be able to point to the screen because I just see a big white patch there.
Yes.
So, well, thank you very much for asking me to do an assessment of your thesis. I very much enjoyed the thesis and your presentation just now.
Thank you.
As I think you've made a number of very important contributions, and I think that it's also very encouraging that you have involved both students and industrial practitioners in your evaluation. That you've taken on some of the challenges that many of the other researchers in this area, myself included, have ducked, avoided because they're either too difficult to evaluate or too tricky. And these are exactly the kind of problems that need to be addressed and also make refactoring practical and useful. So I think it's a very good thesis. Having said that, it's my job to try and pick at some of the details and to try and find a few points perhaps to press you on and to show some natural scientific curiosity and perhaps even skepticism. So I have a few questions, if I may, that are perhaps a little bit more searching, but I wanted to start by saying that I think this is an excellent PhD thesis, and you should be very proud of the contributions you've made.
Thank you, Professor.
So, first of all, I was interested in the statistical analysis in your thesis, and I noticed that you set your confidence level, or the chance of incorrectly rejecting an null hypothesis at two different values, one at the 0.01 level and another 0.05 level, and I wondered what the justification was for choosing these different levels of significance for different experiments.
It's actually because when we have several experiments, we come up with these values empirically. So sometimes you will notice that mainly for when we have a lot of refactorings to apply, like for the case of when we go to the lower level of the source code, we may have triggered several refactorings, and this will try to give more flexibility in terms of the hypothesis. So we'll give it probably to 5%. But when you go to maybe a higher level, which may have less operations, that's when you can be a little bit of tricky, and or probably will have to reduce or loosen up, or no, actually to make it a little bit less to up to 1%. So it's actually based on to answer your question, it's based on the size of the solution that we see in the search.
Thanks. That's a good answer. Can I ask you to turn to page 49 in your PhD thesis?
Okay.
I have a copy here, but that's the same copy as you. Let's find the page myself now.
49.
49.
Page 49. It's going to take me a little while just to locate this page myself, because, yeah, right, got it. Yeah. I think when I say page 49, it's 49th page in Adobe. It's not the 49th page, but it's not page 49. It says table 4.9. Oh, I got your balance. Page 91. Page 91. Table 4.9. I don't have a sensible question again.
Yep.
I'm having trouble locating it myself now. I'm looking my notes from earlier on.
Page 73.
You could say the table number.
73. Yeah, page 73.
Table 49. Yeah. Table 4.9, right?
Yeah, it's 73.
Yes, yeah, it's 73.
Yeah, table 4.9 is on page 73.
Yes.
So as I understand it, you're comparing multiple different techniques.
Yes.
I think it's actually page 11, probably page 91 of the comparison, but you're essentially using table 4.9 is on page 73.
73, yes.
Yeah, so you've got the techniques of measurements on there, MSGA3, IBM, and MSGA3, and so on. And then you're applying these techniques to systems, JHOP and so on.
Yes.
And you say that they're significant at the 99% confidence interval.
Mm-hmm.
But you're actually doing multiple statistical tests there. So I'm wondering, did you account for the fact that the p-values need to be corrected with multiple statistical tests, and were they still significant?
I mean, for all these tests, I use the same p-value.
So if they get a p-value of less than 0.01, you say that they're significant.
Yes.
I think you should report the p-values because
Okay.
if you say they're significant, but the p-value is very close to 0.01, then it could be that actually because you're doing multiple statistical tests,
Okay.
then really you should do some correction of the p-value for that because it's a probabilistic assessment, and so I don't think this happened in this case, but I think it could happen.
Okay.
But if the p-values are very close to 0.01, then some of those may actually be more likely to be incorrect projections of the null hypothesis simply because you have so many statistical tests. So
okay.
what we often do is, for example, do a bond priming correction. It's rather conservative, but you would divide your the p-value that you target, so we'll say one in this case, would be divided by the number of statistical tests you do to adjust the probability to count the fact that you're rolling that probability dice multiple times if you like, so you increase the chance of incorrectly rejecting the null hypothesis.
Okay. Can you repeat again the name of the approach that you suggested?
But what a lot of people do is the most simple thing, which is called a bond corroding correction, BON, bond corroding, BONFER, ONI, yeah, so 90X, which we don't know to the end, but it's very simple technical. What I'm saying is that essentially that p-value is your chance of incorrectly rejecting the null hypothesis when in fact it holds. Okay, so the more times you do the statistical test, the greater you increase the chance that at random you might accidentally reject the null hypothesis when it's true. So it's just a big extreme. Suppose you do 1,000 tests at 1.01 level, but even though you only have a 1 in 100 chance of incorrectly rejecting the null hypothesis in each case, you've done it 1,000 times, so you expect about 10 of those to actually be, although you get a p-value less than 0.01, they would actually be about 10 that would be incorrectly rejected. Let's see. But if the p-values are really very, very low, then it might be that even after correcting them, they're still only having 0.01 chance of rejecting any of them. So that's why it's usually considered best practice to report the p-values in the table so that people like me who are pedantic but can do these kind of calculations for ourselves.
Okay.
This is, I was wondering also about the effect size and whether there's any way in which you can measure that. All the significance test tells us is that the median of one is definitely unequivocally better than the other, as it were. That's rather imprecise way of putting it, but it doesn't really tell us whether that's useful to the developers. I find this quite hard myself, so I'm really asking you to see what you think about how you can assess from these kinds of numeric results whether the improvements that you get from one algorithm over another are really useful or valuable. Is there anything along those lines?
You mean for the improvement in terms of? I'm sorry, I'm not quite understanding.
Perhaps I'm not being very clear. When you do a statistical significance test, you know that if you find a significant result, then it means that there's very little chance that you would find this median is higher than that median value.
Oh, yeah.
Really by chance. But that doesn't really tell us whether the improvement that one algorithm gives us over the other is really valuable or useful or somehow whether the effect that using one algorithm is better than another. I wonder if you have any thoughts on that.
I think it has been reported, but it's missing in the report because I used the Koenig the value for that, but I don't see it being here mentioned anyway. So maybe yes, I have to probably report that. Yeah, it's missing on the report. Yeah, thank you for this too. I have to add that. But it's missing also in this part. Yeah. Yeah, it's missing.
No worries. It's only so many minor details. As I say, the thesis is very good, so it puts me as an examiner in a difficult position because I still have to try and find some things to look at. I'm sorry about the break about it. I think I should hand over to my colleagues now, to Professor David to answer for their questions. So thank you very much for your thesis.
Thank you. I'll make sure to take this into account.
I have a few minor points, but perhaps we could talk about those at the end.
Definitely, yes, Professor.
Hand back to the chair now.
Yeah, thank you so much, Mark. So thanks for all the comments. So yeah, Professor Kalyanmoy.
All right, so I completely agree with Mark. It's an excellent thesis. We've done a lot of work. I think the interesting thing is some theses tend to be more theoretical, some theses tend to be more practical, if they're particularly solving a practical problem. But what you are able to do is that you've got some theoretical developments in the multi-many objective literature and take them and use them for the search for software engineering area. And also just not presenting those results, but you have used them on some number of practical softwares and also interacted with software developers to see what their views are and how their views have changed and incorporated their views into it. So I think overall, in every respect, it's really an excellent contribution, I'd say. And also, thesis is also well written. There are one or two minor things that are getting later that you can fix, but that's mostly in the library work. But there are 3 or 4 areas that I would like to discuss and maybe this would be good for thoughts for you to do from now on in future studies. So first thing is that so there is an existing software and maybe a number of software that you're trying to improve. And then you have a methodology by which you are considering a number of different criteria that relates to the quality and time of execution, all that 1 of 7, 8 different objectives that you have. But one of the things that may come to somebody's mind if I am the owner of the software and you are coming to me and asking me that you can do this study with the software. First thing that comes to my mind is how much time is going to take, how much cost it is going to be for doing this whole study, and then how much benefit I'm going to have after doing this stuff, right? After doing the study. So do you feel that at some point you need to also do a study or include an objective or a criteria, maybe as one of the objectives or maybe as one of the decision-making criteria, where what is the transformation cost in terms of time, maybe money, efforts, all that stuff. So I don't know whether you have included some of these in this, but I don't think you have those. Yes. Have you thought about that?
So far, it has been done with, let's say, approximations, because you go to developers and they will ask you how much time do I need to do this. You will start thinking about it. You don't even have any. So to answer your question, I don't have anything that can help me decide about that. But in the literature of software engineering, we have been already working on defining a lot of metrics that can help us estimate the effort of the developer, estimate the cost, estimate the testing, etc. So if this can be included in my approach, as for now, I may not be able to do this, with this kind of methodology. Maybe if I can go to the multitasking level, then I can, because these can be represented in a heterogeneous way. Because if you want to even take them as a search-based problem, which can be done also. So they can be included with this work, with maybe with the multi-testing. As I'm trying to include the estimation of the effort of testing with the refactoring, I may also include the cost of the refactoring and the cost of testing into another fitness function for another search, which is able to come up with a better decision making in terms of how much of time and cost we want to spend on this kind of project based on these constraints in terms of budget and time limitations. So maybe it's like a one layer then it can go up to my work. And definitely it can be feasible, you know, yeah.
So that brings me to my next question is about trade-offs. So when you have multiple criteria, it's all about trade-offs. So you know that there are non-dominated solutions that you're finding. So that means you need to sacrifice at least one of the criteria in order to gain another. So that's how there is a trade-off. So the amount of sacrifice versus the amount of gain is very important when making those decisions. So on this existing software that you look at, there was a version before, and after you modified, there is a newer one. So you can maybe go back and do that how much changes you have made. So that maybe to how much time or effort or money is going to change that versus how much efficient you made. So that trade-off, that ratio can tell, see, you could do so much. And then you can go to a new developer saying, on a similar software, you have so much trade-off. So it's just a little bit of extra work from what you've already obtained. It's just computing that trade-off is I think, important indicators or why someone would like to do this.
Okay, so I can take all the changes that I have recently done and then measure how much of a change I did and how much I can estimate how much of effort the developer has. And I can ask the developers to tell me or share with me how much time they spent. And then I can take how much gain you have done in terms of quality and build the
Exactly.
It's going to be a Pareto, of course.
Yeah, so it's going to be trade-off. So you can take this one criteria for how much improvement you made, one criteria or one kind of composite criteria that would say how much effort is. That's trade-off. That's the willingness to do that.
It's a good idea.
Yeah, so it's just following up on, you're in the right track. Just taking some of these metrics, which one you're going to take, you have to decide. It's just one measure, and that could be an interesting number to tell people that certain users is growing. You could do some of it. Moving on. So you mentioned that you started with a random population for the 15 and 22 searches, and the number of variables that you have here, I'm sure that quite large. And so if you randomly create some of these notes and assignments, represent solutions, maybe many solutions in the beginning are meaningless. They probably are invalid notes, as you mentioned, some of them are. So then one of the ways to do that would be to think of some way to see the and various things you talked about, like analytic approaches, manual approaches that people manually fix stuff. So why not take the current software, use some of those existing ideas, which is either manual or analytic or some of those or these professors' algorithms that you're using, and see your populations with those. And then the effort of the evolutionary process may not be that long. Maybe only thousands of populations. Because you already started to make it. Now, sometimes you can screw it up because you have taken a seeded population in a way that it's already biased towards certain direction. So the evolutionary search cannot take you out from there too far away. So you're stuck with in the solutions that span so points. So that could be an issue. But I think there is a study to see if I seed my initial population with some of the known methods instead of this random, how much can it improve with an SPH and things versus if I start with it. And then you said also it's like, okay, 50% of the population I do with existing knowledge methods and 50% random. So you vary that and see where lies a good trade-off of that. So that could be another future study because I realized that you're dealing with the problem, it's very difficult to come up with a feasible solution at random. Right? So
that's true because follow up with what you said, which is perfectly makes sense because I count, if I look at it like the very beginning of the accumulation solutions, we have several embedded refactorings already. We have several embedded populations. And they get penalized through the search. So they will be removed or they will be just fall behind. But that makes sense because if I'm able to, because that's, so the only thing I'm doing is it's costing me much more time to evaluate. So it takes me much more time to evaluate to come up with the good solutions. So it does make sense if I'm starting from an existing or a better set, definitely, maybe I can do better. With also the concern of I may also be biased to one.
Too much better than
So this is again a trade-off in which we have can be kind of how much of good we have to start from compared to just pure randomness. Yes. Thank you, Professor. This is also very good.
Okay, I don't have more. So with the immobilization part of your work, the second part of the interpretation too. So you found the two objective front, and then you're ranking the solutions based on what proportion of commonality it has with the rest of the quantity. That's a very good idea to really rank it that way. In some sense, you're saying that how much it agrees with the rest of the solutions.
Yes.
It's answering my trade-off question in some way, okay, but in a very indirect way. So one of the things which you mentioned in this as well is the viewpoint, right? So in some cases you found there are views in some cases. So trade-off is I really come back to trade-off again and multi-objective. That once you found the front, not every point in the front is preferred. Particularly if you have a new region, a new light region in the front, then usually decision makers like those because the trade-off is good. The trade-off is excellent. There is no motivation for you to go out from these and look for that. Trade-off is good. That's how the whole bank is going to shape. But you don't know that before you found it. So that's where your method comes in, that I need to find it, and then if there is a new light feature in my front, these are really the solutions that is interesting. So in my normalization work, I also talked about lower level. That means instead of doing the normalization on the whole front, we can concentrate on the unit. So instead of looking at commonality in all solutions, where some of them can be not preferred eventually, you look at how much they are common in the unit instead of the whole thing. So that way, the units are preferred, and you're saying out of your preferred solution, so much percentage this solution has commonality. So now the ranking gets a bit more meaningful. Yes. So this is just innovation we call it lower level innovation. But that's something you can try and see how does that change from your current study. Are you getting the same ones, or are you getting some other ones ranked better? So these are some broad comments that I had in page 120. So that will get when you're in this table 5.14. You mentioned NSDAP / group PA parameters. Now, what is this number for usually?
Is the one that we use to know how many reference points we have to put in the head.
Oh, that's the reference point, number of reference points.
It's the number of, it's because you have the ratio that is the field which is divided by the number of divisions, basically how much of reference points you put per line, per reference line in the head.
Okay. So that you're using also same for MOAB, but in this case,
yes, we are using only with that, only with that algorithm, because that's the common parameter that came.
Yeah. Okay, so I thought you may also say that because it caught my eye because NSDAP does not have any parameter. You don't need any parameter, but number of lines is needed.
Yes.
That will maybe equal to the population size. So if you want 10 points, you should use population size 10 or 4. Yeah. So when you say NSDAP parameter, it caught my eye because I thought you didn't have any parameter.
Oh.
But this is actually equivalent to population size, but that's also common with other parameters. Okay, so maybe you can just mention that as a common parameter to also the other methods. You And there and there, if you think of like page 126 if you go, the title of these figures are found on page 126, that the figure is on 127. Get some of these things. Just exactly what's the outcome here. Page 126 bottom. Oh yeah. So just go through the pieces once more and see if any of those things are answered. The last common question that we have is how much time, computational time it's taking to run your, let's say, the RP1 and RP2
For the refactorings, it takes a lot of time, like over an hour or two sometimes.
for one algorithm.
For one algorithm.
Okay.
Yes.
That's not too bad. This is offline.
It's offline. It's one time, it's one shot.
Then you go into
Yes. And also it depends on the algorithm itself and how many objectives and the size of the solution as well. So yeah, it's mainly, it can be parameterized, but usually it's an overall.
then the wonderful pieces and have so many things factored into one. And you have a lot of other ideas that you have that you can follow on. Thank you so much.
I'm not sure. I'm hopefully one to start next.
Okay, sure. So, Professor Medjahed.
Yeah, thank you, and I would like to join my colleagues from the committee in thanking you about the very good quality of work that you did in your thesis. So thank you again. I have a few questions, but I would like maybe to focus on the parts that we didn't have time to cover in your presentation. I see that you have a few other contributions that you made. So can you tell us, so one of the contributions dealt with uncertainty.
Yes.
So can you tell us a little bit about it? What is uncertain in your environment?
The developers sometimes, it's this observation. Developers, first of all, it's because developers, they may not be sure about what are the main classes that you have to update. Sometimes they'll give you, I know that I want to update, for example, this package, but I'm not sure which are the classes that I would like to actually update. And they may be able to know that through when they are actually working on refactoring itself. It means they may be starting with a design in which they would say, okay, this class A is my class that I want to update. And then by changing this class, they will discover that, oh, maybe class B has a better refactoring opportunity. So why not, move to class B as well while I'm changing the source code? So this transition cannot be done. I mean, if I'm requesting several operations that has been done based on one observation in which all the classes that are equally looked at. Or I can give priorities to the class and say, this class A has a better priority for me to look at, so I would recommend and give more credit to any refactoring operation which is changing that class instead of the other. So this is the two ways in which we find the report. So either giving equal like weights to all the classes, or giving a priori, giving all the weights for our priorities for different classes. What happens is if I want to change the priority of the classes during the search, this is the work that I'm trying to do. I'm trying to be able to update the priority of the classes all the run on the fly when I'm optimizing. I would do that by simulation. So I would take the priorities of the classes and change and create what we call here perturbation. I would change their values. Like I would say, for example, that class A was, has higher priorities. Now class B has higher priorities, and I would see if I can update this one. How this impact the search. So the search here would start, first of all, moving towards or favoring solutions which are going to change mainly class A. Now they are moving from class A to more solutions or solutions that will be updated in a way they will change and move to this class B. So I want to see what is, because here we are no longer going with the straightforward optimization in which we know where to go in the search space. Now it's like a little bit noisy. You don't know where we are going. So because I don't even know prior of time what are the changes in the priority of the classes. So this will give us solutions which no longer as optimal and as good as the previous solutions, because during the search phase, we change these values. So the search will go, for example, towards fixing this set of classes or towards this set of classes at some point of time, depending on the changes, which is also being done random, because I'm doing it random for this experiment. And by doing so, I will be able to come up with solutions which are not as good as any solutions which is primarily fixing, for example, this class, but they are robust enough to give a good trade-off in fixing maybe both. If both of them were at some point of time being the main interesting classes during the search. So the solution will be, that's what we call robust solutions.
So did you get a chance to look at some stochastic models or probabilistic models on that? So what kind of model did you use to represent uncertainty in your case?
The uncertainty in my case was done through what I didn't use any model. I was just taking the values of the priorities that I set in the solution, in the process, and I would just change them randomly. With of course, it's a small change, which is it can go up or can go down. It's like, it's a small change, but no perturbation. So I didn't really use any specific model.
Yeah, with robust, there is two main categories. People are using statistical probabilistic models, and there is robustness or uncertainty and optimization. So the second approach. So the uncertainty is mainly, as Mohamed said, the possible changes in priorities over time. So how you can improve it.
Very good. So my next question is also about another piece of work that we didn't have the time to present here, which is the very first one in the top here, which is going from a model to another one. So this is something that has been also handled by other research communities, maybe people that work on data integration. So mapping between ontologies, going from ontology A to ontology B, or by the database community going from a schema to another schema. So coming up with rules that would automatically take you from one ontology or one schema to another one. So did you get a chance to look at that and see how your work compares to that?
Because definitely, it's a good observation. This is actually how I did my validation. If you look, I did the cross validation. So what I did is I took an existing subsystem. I took Wiem national rows, which is able to take automatically any class diagram and define it into rational schema. It's already been solved. So we have several tools to do that. And I took several systems, several models, and transformed it into rational schema. And my work was trying to replicate these changes and see if I can do the same. So the question will be here, so if it's already been done, why would you do the same? It's because I'm trying to make this generic. Because these pieces of work, they were done only for the class diagram to the rational schema. But my solution, or what I'm trying to do, is it should be generic. So as long as you give me a model A with meta-model elements and a model B with multi-model elements, I can try to come up with transformation rules between them. So my goal was to make this more generic. And that's why when I tested also, I tested against other kinds of source and target models.
My third question is now about the second work that you presented, which deals with interactive software refactoring. So, in the possible case where you have multiple developers that could deal with certain tasks, how would you go about selecting the right developer to seek feedback from? So, did you get a chance to think about that?
That's a very interesting observation. Yeah, as for now, it's only single user approach. But this is a very nice observation because the development is actually it's a mutual task. And mainly right now, everyone is just working on this risk. So when they use my task, they have to stop. All the others have to stop, and only one developer is acting on the code. And this is one of the limitations of my work. And to be honest, I don't have any guidance on how can I extrapolate this into several users because it's an interesting observation, and it's maybe can be also a very nice contribution.
Yeah. Last question is more philosophical here. It's about the title here. Can you tell us a little bit about the title? So you're talking about competing needs of machine and human. Can you tell us a little bit more about that?
Yes, it's the title actually, I had actually another remark about this title, which is interesting. He said, why would you put the machine before the human?
Yeah.
Why do you say convenience between human and machine? And this is maybe because of the chronology of my contributions. Because I went into satisfying the machine first by giving a fully automatic way and incorporates, several, as you see, preferences. And then I decided to no longer do that and satisfy me. Okay? Because I noticed that this can be scalable, this can be nice theoretically, but it's impractical when it comes to the human level. So that's why I decided to move from the fully automated into the more interactive and incorporate developer into the loop. And I felt like I'm moving between the machine in terms of fully automated approach and the human in terms of interactive approach. And I felt like I was looking for the right balance between them. And that's from where I come up with the convenience between having fully automated approach, which allow us to avoid having the time-consuming and human-intensive tasks, but at the same time, we should not remove the human out of the loop because the human will be the actual, after all, decision maker and the one who would benefit from these approaches. So being as close as the human behavior is also very important. And this will be always maybe an open question. So I'm trying to investigate this person every question.
Thank you, Mohamed.
Thank you.
Okay, yeah. I fully agree with the previous committee members' comments on the quality of the thesis and excellent job you have done. And I'm very impressed by you have made the contributions, not just one area. You have made contributions at all the levels of software maintenance, from the model level to package to source code. And very impressive in terms of methodologies you apply this multi-objective optimization techniques to the software engineering maintenance, and also invented this dynamic interactive refactoring approach, which is very impressive. So I do have a couple of questions, and one of the questions is for this matrix values used for this optimization. One of them you said is like number of classes per package for the number. Have you ever thought about different classes, the complexity, the size might be different, and does that affect it's similarly you have a number of rules, and also the different rules and you have different complexity and so on. Have you thought about if you use weights or whatever to instead of just the number of them, and instead just number related to them? So if it's a larger size, you have more weights or whatever. So is that what affect your result?
It will definitely affect the results. And you're right, because some of the work they actually use weights.
Okay.
Such measures.
Right.
But for this work, I mainly use, because if I recall, if you allow me to go a slide in which I have the different measures.
Mm-hmm.
So for these measures that I have used, all these measures they have been used mainly on theoretical work.
Mm-hmm.
So that's why I was using these measures.
Okay.
But definitely there's other work that can be also, or there are other measures. And if we go through all these, we may also be able to come up with maybe, let's choose better representation of these spectral similarities. There's a lot of work that has been done there, and maybe by doing so, I can maybe get better results in these approach. Definitely.
Yeah, that's fine. The second question is for this user developers feedback. How do you get that? You just make one solution suggested, ask the developer to accept it or not, or you present a set of alternative solutions, ask them to rank them, in which way you did?
Okay. So the classic interactive approaches, they would include the developer in the loop of the process here.
Mm-hmm.
So you'll see the developers taking several solutions which they belong in this parental front, like here. They will take solutions and then they will look at all these refactorings and say this solution is good, this solution is bad, this solution is good. This is how the review work has been working. So they were working exactly like you mentioned. But for my work, I want to do something different. What I did is I came up with a ranking for the solutions. So this ranking has been done in a transparent fashion, so the developers, they don't see that. It's already been done in the back end. Then what I'm going to send is going to send one solution to the developer, and this solution has several operations. So I'm sending the solution operation by operation. And the solution that I'm sending is the one which has a better initial ranking. And then the developers can accept or reject this one operation at a time. Okay? So this is, and by doing so, I no longer incorporate the developer into the search exactly here, because I'm incorporating actually only, let me see, I'm incorporating only these changes that can be sent back as constraints to the search. So his behavior here, in terms of accepting, rejecting, modifying, that behavior will be sent once the developer closes, for example, this application. So I will be able to take all these feedback and back to the search, and by doing so, I can put these as constraints. For example, if the developer was interested in some part of the source code, so he'll be applying a lot of refactorings there, and he's not interested on the other side, so he'll be denying a lot of operations there. I will take this information about what are the sides that has been denied and what are the sides that have been accepted, and put it into the search. Okay, and then any solution will be having operations which are closer to this side that the developer likes. They will be better, will have a better rank to survive, like it will be going through the evolution. And any solution which has refactoring similar or dealing with the side of the code that the developer disliked, they will be penalized for that. Okay, so they'll have less time, they will have a less fit to stay in the search. And by doing so, the next bunch of operations or solutions that I will be ranking again here, they will be all mainly focused more on the region of the interest of the developer. And this is how I can get closer to what the developer wants.
Very nice. Yeah. The other is a general question is, could you explain the differences between multi-objective versus many objectives? I saw you use both, but I just wonder.
I wouldn't be answering this question with the Professor did, but I would say that a lot of work has been done during this, and usually they switch, or they mainly, a lot of, it's again, a lot of papers that will define this threshold to 4 or 5 or 6 objectives.
Okay.
Yeah, so several studies that can do that. Yeah. So it's again, looking at several papers, you'll have several thresholds depending on the problem.
It's kind of arbitrarily said. I have not decided that. I could have decided that more than 3 is many, less 2 and 3 are not. And the reason for that is these algorithms like SK2 does pretty well for 2 and 3, then going 4 onwards because of the reason that you mentioned, that the number of points in the population exponentially grows. The algorithm doesn't get the way it should be. So they need a different kind of value. So the cutoff is around from 3 to 4. So based on that. I don't like the counting like that. Say what
Okay, thank you.
Yeah, I think someone. So, Dr. Maxim.
That's a helpful. Again, very good job. Very interesting experiments. Nice structure the way you experiment it together. A lot of people get impatient and try to combine too many things. You get patient. Work through one variable at a time, which you add things in, especially if you interactive experiments. One thing that sort of has always bothered me mentally about genetic programming is the random programs you generated initially when you do that. And to a certain extent, I wonder if that doesn't make it seem like it's a very artificial task for professional developers that are working on stuff. So how much effort really needs to go into building that initial random population is really not random algorithms that are being refactoring, really just the rules for it.
Yeah, you're right. I mean, you are joining your point, the same point that Professor said that, I'm joining a lot of maybe useless and, a lot of solutions that have several operations that may be not as the best that you can do, and also they may have you can have a lot of conflict among even these operations, which makes sense because taking those into the search will actually cost us much more time to get rid of them, if you want to say this way. So yeah, it makes sense for me to maybe come up with a better way to start, looking at what people have previously done to do better than that.
I mean, I understand the whole purpose for doing it is that you're likely with the genetic algorithm to uncover a solution that's not been plot through,
Yes.
at least not by human beings. I'm just finding it hard to sell that to someone because, again, I have an economic model of software engineering too, and it's what's the cost and benefits of doing this stuff. And usually the answer is you save money in the end and have fewer defects, therefore it's a good solution.
But the good news are that evaluating these solutions, they cost us nothing. If we are taking search space software engineering and moving it into maybe other field like mechanical engineering or electrical engineering, in which starting from a random solution will give us a random model, and the simulation of this model will cost us, for example, $1,000 to see if it's good or not. That's when we have a problem.
Yeah.
But since that we are acting on a source code, and the source code is virtual, it costs us $0 to evaluate if the solution, if this operation are good or not. That's how we escape, from that situation that you definitely mentioned, which definitely has a problem if we move maybe outside of, the search space of
the other thing too, I'm looking at the title of the dissertation. What human needs get in the way the most with trying to do this work?
So what human needs?
Well, the title of the dissertation is Balancing Competing Needs of Human and Computers in Space Software Engineering. So what human needs get most in the way of doing this work?
The human needs are an optimal, software that can give you the best design ever that can match exactly what you want.
I was thinking of going back to maybe some of the things you talked about when you're talking about things like you can't get developers to take the set of refactorings and go and do them in order because that. Yes. I'm just wondering if that was more the kind of stuff you were referring to because I can see the way most programmers behave. They start on 2 or 3 refactorings and list, oh gosh, I should fix this too. Yeah. There's no reason I should leave it. And if I put it aside, I'm going to forget. I'm not going to come back. So I was wondering if you had other examples of things like that you observed in your work.
Of course, I mean there's several things because, as you mentioned, the developers may change their minds during the refactoring process. And all those other developers don't know what they want.
Exactly.
That's another thing. That's the algorithm knows where the algorithm has to go, but the developer doesn't know where to go. And us, to satisfy the developer, we have to make also the algorithm go to where the developer wants to go, even though he or she may not know where to go. And we notice that this may not give us the best results, as we noticed that during for example, for the number of code snags, we did not do good in terms of fixing the code snags. And that's because the developer, just following the developer. We don't follow. It means we deviated from the nice numerical, theoretical objective that we want to reach. We no longer look at that, we're looking at what the developer wants on the runtime. And this may take you to something that you like or not, depending on, and this is also subjective, right? Because several developers may have several behaviors during their refactoring. And this is actually a nice observation because we may think of also having this kind of profile-based refactoring in which we can learn about the behavior of the developers through the refactoring, and we can start clustering developers based on their behaviors. So it's a very nice observation that can also take us towards such contributions. Yes.
That's all for me.
Thank you. Okay. Thank you. All right. Thank you, Mohamed. I enjoyed reading it. I start out by admitting that I'm not either a computer scientist or a software engineer. And so the questions that I really have is there an application here to kinds of problems that I consider? I might have a model that has several 10,000 lines of code, and one registry has modified it, and then another registry comes along and has to understand what has been done, and the code is not always written in the best form. So is there anything in this that easily understood model but preserve the physics of
what's going on. Definitely, this is exactly the heart of my work. So my work is to be able, as I have previously mentioned in the first slide, is that the developers, they spend 60% of their time understanding the source code.
Yes, I know it's typical of graduates.
Yes.
One of my graduates spending about a year.
So we had a good example, yes. So my work is trying to correct that situation, trying to reduce, not to eliminate, unfortunately, but to reduce this time frame into a third time frame. So because we have in software engineering quality attributes that can look at the software and say, this is how much of understanding we can do from the software. We can measure that. So we have tools that I can share with you as well. It's not only my work, so there are several works, including mine, that can help the developer to, first of all, understand the features in the software. That's what developers usually look at. And also, we have ways to detect if there are flaws in the software. We have tools to do that as well. And my tool will be clustered in the tool that can refactor and help the developer have a better design of the software. So yes, the application of this work is there. And go ahead.
Is it correcting errors in it, or is it simplifying it, or some of our software converges and it's sort of dynamic. If it doesn't converge, it goes back to smaller intervals. Is it helping that process to convert it, or letting it? I'm trying to understand what it's doing.
Exactly. We are improving the structure of the software. We are not changing the behavior of the software. So what you have mentioned won't be touched. So the refactoring, it will just look at the software. It will change the instructions, the design of the instructions, without changing how they work. So the software will be transparent. It will be running the same for both. This is the software before we update, and this is the software after we update. The results will be the same. If we run the same experiments, we'll get the same results. But the design of the software behind is different. And this will not be visible to the user, it will be visible to the developer of the software, because the developer will be looking at a spaghetti code here, while here it's a well-designed code. So updating the software later will be easier after applying this requirements.
I understand. So it's simplifying the source code, making it easier to understand.
Is there any type of code we're often using computer languages for that?
That's actually for Fortran, we can, unfortunately, we cannot apply this to Fortran because the way we measure the quality of software is based on what we call object-oriented software languages. That's why people are moving out of Fortran, because people can know, like, we have to have rules to say this is a good software and this is a bad software. And it's easier in the object-oriented design languages to say this is a good software more than in Fortran. Fortran, if you try to apply the same thing I'm applying right now, you may end up having another false positive. You may not be looking at the same way as the source code. Yes, Fortran. I made it, and then it might have, because to my knowledge, I don't know any tool that can help you with Fortran, but I'll look at and I'll get back to you.
So one guy working in Berlin, identifying inputs that will cause trouble to the software. So you may not, you may face it once you give them a try, inputs and inputs, the software will be doing it. So if they have other methods that you can identify what are the inputs, so that can be the developer identifying is not easy by random methods, and you are optimizing search methods to help you find those. So this is one of the cases where optimization is to identify faults.
Thank you.
Thank you so much. So yeah, I will try to maybe summarize my how then also come back to I also clarify some of the so first of all, I would like to thank the committee for the very interesting feedback for the work done by Mohamed. So Mohamed agreed the great PhD, and I very energetic student, and either in terms of understanding theoretical work or theoretical work, and they find that the real world is a problem. And other than that, they can say that Mohamed was kind of, say, leader of my lab, who is making the integration smooth for other lab members. So I really appreciate the work done by Mohamed in his PhD. And I believe the work that is done by Mohamed show the applicability of search-based software techniques in industry and in real-world problems. It's not just about theoretical models, etc., but I believe based on the experiments that he did and all the work done in the real-world setting, it showed that SBSC can be really great results in real-world setting. And some of the work that he did, of course, he provided prototype to the IT department of work, and they are planning to have a release like of this interactive refactoring idea in the future. And I believe, the work done by Mohamed touched two different aspects of the communication, and I believe it's really kind of something good. To come back quickly to some of the very interesting feedback, I believe that yes, I believe that we have to maybe contemplate some more details about the Brahim design, science, etc. You do that in the paper, but I believe in the dissertation that is just part of the dissertation. And also regarding the observation of Professor that yes, I believe that the way that Harman is just to estimate the report is just based on how many refactorings you are applying, and we try to minimize the number of refactorings. But as you mentioned, it would be great to maybe use maybe kind of predictive modeling approaches to estimate the report, because already in the software information when you search the property models and of trying to predict the report. Not really applied to refactoring, but really for prediction, etc. And I believe it would be nice to explore this research direction where we try to combine machine learning with SBSC in your search when you are trying to evaluate your solution based on predictive models. So that's, I believe, something that Mohamed can explore in the future. And also about the innovation part. So I believe that the work done by Mohamed now is more to answer that question, how you can have the user to implicitly explore the hierarchy. So we don't, because when we start, for example, for collaborations with people in the industry, they always kind of complain a little bit. They say, oh, you generate many solutions. We don't have time to look through all the solutions. Even they find difficulties to, let's say, translate the preferences in terms of values. Like for them, 0.8 of it doesn't mean a lot of stuff for them. So that was the main motivation of the work. How can we implicitly push the user to explore the microphone? So we just try to show part of the solution, like refactoring by refactoring, and use this interaction to calculate the ranking. So it's actually what we are suggesting. So instead of telling before the execution of your automatic language what would be the region of interest, we try to learn that by interacting with the program. So I generate a solution, and based on that, I can move between the solution and the parameter on based on that interaction. So partially turn the solution to the program, and then after over and sometimes if after a number of interactions we have many like rejected refactoring. So in this case, we execute the lockups to repair the parameter. So that was the goal, is that instead of telling us at the beginning what would be the reason of interest, we try to learn that after signal. And I believe even the evolution computation error is pretty also massive. Also, yeah. Yes. And I believe for the observation of Professor Medjahed about title, this is the connection. I believe one of the, let's say, question that at a very high level that I'm trying to answer is, to what extent can you automate the solving software engineering problems? Because I believe that the software engineering community try to automate, let's say, everything. So every problem you take it, you try to fully automate it. But at some point, you may realize that the human is in the loop, and sometimes it's hard to fully automate everything. For some problems, it makes sense. For some other problems where it's very subjective to evaluate the design, or you need to have the human group to take control of what changes are introduced in the code, you cannot just say, I want just to use a machine, which means like fully automate that process at home. So this maybe high-level question that I'm trying to answer it based on these case studies on refactoring. To what extent can you automate this software engineering problem? So yeah, that's just some observation. So since you are in an exam, I have to ask you maybe a few questions and some general questions. So in your introduction, of course, let's say there is 3 ways of possible interactions. You can interact with the user before executing, let's say, your refactoring, like your algorithm, like your refactoring. You can maybe do the interaction during the execution of your optimization algorithm, like what you do in your work, or you can do it after, by maybe exploring. So I believe your work was maybe more around trying to better interact with the user during the. So how about the 2 other possibilities? How you can maybe better interact with the user even before executing your algorithm or after the execution of your algorithm? So if you have any ideas how you can maybe
for the interaction with the user before, it's kind of investigated in the reference-based evolutionary software refactoring, because at this point we are taking the reference of the user as a reference point that we inject in the resource space. And well, that was basically the advantage and also limitation of the work, because the advantage is once you have this point, you know where to converge, but the question is how to come to this point. What are the values that will represent best the preference of the developer? And that, of course, is hard, for us to answer. So this is for the a priori work. For the posterior one, which makes us maybe explore the Pareto form in a way to allow the developer to have a better understanding of the solutions. That's something that can be investigated, maybe using, a better way to give the developer a vision of how these solutions will perform. Like if we have any visualization tools that can help us, for example, visualize what would the refactoring would look like, because so far we actually visualize what is happening, what's going on. But if we print the Pareto form and take for each solution, and if this, for example, the developer will be able to click on the solution and get a picture of what would this design look like, maybe that would help the developer also have a better way to understand, these solutions. Then it will be just simple, like we will be able to visualize and see the differences between the designs. They can be similar, of course, because all of them they have a high number of similar refactorings, but at least they will have several other changes that can be seen and visualized. And the developer, instead of looking through a long list of refactorings, he may be or she may be looking at a nice design which allows them to distinguish right away the differences between these designs and make decision making based on such situations.
Okay. So my second question is about your contribution or the main objective on software modernization and software refactoring. Because there is some recent studies in some recent work done by professors that they try to understand or refine, let's say, the correlation between the objectives. So, for example, they try to execute the multi and many objective algorithm with a different objective for the number of iterations, and they try to see if these objectives are correlated or not. So, and that's what may reduce the number of objectives that it's kind of dimensionality reduction in the think that maybe this kind of approach, maybe, I don't know, maybe converge faster if your object limit conflicting somehow, or if you identify some correlation in some of the subjects instead of using 15 correct objectives, maybe trying to combine between some statistical algorithm, search algorithm.
That's true. Actually, when I worked on the main objectives of refactoring, and one of the work that I had done in Deco was a comparison of 15 objectives. And I remember that one of the previous is what's the level of the conflict among these 15 objectives. And yes, and on that point, I was relying on the fact that if we have not necessarily objectives that are conflicting, then we are maybe wasting some time doing the search, because we are still going to have good results, but we are actually doing much more iterations and much more effort towards looking at conflicts which they don't exist. So they will be better to, for example, reduce the degree of conflict between these objectives, and have work that has been done towards that. But for example, for the next work which has been done in 2014-15 in domain objectives for pre-modernization, I actually looked and compared between several objectives one by one, and as on the paper it shows that these objectives are conflicting, and I was sure that by running these objectives, I don't risk having any, or I'm not wasting any time. But it does make sense that still for a generic level, so either by not studying the conflict between the objectives, or by studying all the conflict between all the objectives, by taking them two by two, we are not maybe doing we are doing a human, we are doing something which is human intensive. So maybe if we can come up with a generic way to study the conflict between them, that will be better maybe as a future. Yes. I haven't looked at that
So,
yet.
yeah, my last question is, it's more about the data that you are collecting based on the interaction with the user. Because when you interact with the programmer, you are collecting, I believe, very relevant data of what refactorings developers are applying, what refactorings are rejecting, or what refactorings are modifying, etc. And I believe this kind of very relevant data you may use later when you execute again your algorithm, data maybe for neural linguistics, something like that. So maybe you can use the same to converge faster. So you can learn maybe from this data using your innovation component. So, for example, this programmer, he don't like to apply a lot of refactorings that are part of this, classes or packages, and he prefers to apply more refactoring than some other, packages in the code. So this relevant information you can maybe learn them, and you can maybe as constraints for the future execution of your algorithm. So thus we create kind of, let's say, profile-based refactoring, where we take into consideration the profile of the programmer, what change we introduce in the past, what refactoring we applied, and maybe that will help you to convert faster in the future based on what you learned from this data. So do you have any idea how you can, let's say, explore this idea in practical perspective, what you can use?
That's again, it's almost the same question of Professor Maxim's as well, as how we can learn about what has been already been done. As so far as what this work is concerned, once the developer closes the Eclipse, all the data is lost. So I don't keep track of what the developer has done, which is again can be done in a better way, like we have just mentioned, by saving and logging, for example, the behavior of the developers or the member, like in terms of number of executed refactorings, etc., and the number and what candidate classes the developer has changed. And by having this data, we can use it later on, to maybe understand better how the developer refactors the code. But again, we are trying at this point, we're trying to automate the behavior of the developer, which is again a problem in which we may not be also sure of, because the developer may change their mind later. The way they change the code maybe also changes as well. So how can we approach that? It can be also very interesting in the future.
Okay, thank you. So thanks again for all your hard work on the PhD studies. So I know that you are now maybe dealing with some offers, maybe extraction topic, but you have to wait until
decision of the committee to approve or not your so the committee, if there is no other questions from the audience, so we need maybe 5 minutes in order to discuss the item. Oh, yes, sure. Yeah, no cameras or.
You can look at YouTube.
Because they are